Hi everyone, let's talk about the real-world applications of transformations of quadratic graphs, or aka word problems. Alright, so today we're going to talk about word problems involving vertex form of quadratic functions. So number 1, arches. A parabolic arch, or parabolic arch is used as a bridge support. The graph of the arch is shown to the right. If the equation that corresponds to this graph is written in vertex form of a quadratic function, all right, what are h and k? So we know that h and k are dealing with our vertex, right? H and k are the points of our vertex, and we know our vertex is right here. We know this is going to be x equals -1 and y equals k. So our vertex is going to be -1, 5. So what we want to do, -1 is our h, and our k is going to be 5. It's as simple as that. And that's our answer to this. Number 2, profit. A theta operator predicts that the theta can make -4x squared plus $160x per show if tickets are priced at x dollars. We want to rewrite the equation y equals -4x squared plus 160x in vertex form. So how we do that is by completing the square. So first thing we want to do is set, I want my pen, not highlighter. We want to set -4x squared plus 160x equal to 0. All right, because we're going to rewrite this by completing the square. Then we want to factor out a GCF of -4. So if we factor out a -4, we end up with x squared minus 40x equals 0. And then we're going to be completing the square, so we want to take our b, which is -40, divided by 2, and square it. So we end up with -20 squared gives us 400. So our magic number that we're going to be adding to both sides of the equation is 400. So on the left, we rewrite as -4 times x squared minus 40x plus 400, all right, because we're adding 400 to the left in order to make a perfect square trinomial. Now, what I want you to notice and be careful about is we added 400 to the left side of the equation, but we're really adding -4 times 400 to the left side of the equation when we're putting it inside the parentheses and completing that perfect square trinomial. So we have to be careful. On the right side we had a 0, and we would normally be adding 400 to the right side of the equation. But you have to be sure to balance out your equation. Whatever you add to the left side, you have to add to the right. So we have to add -4 times 400 to the right side of the equation. So always be careful whenever you're completing the square to make your perfect square trinomial, and you factored out a GCF first, you've got to balance out the equation, and you have to multiply whatever you're adding to the right by that GCF, by that number. All right, so on the left, if we're factoring that perfect square trinomial, two numbers that multiply to 400 and add up to -40 would be -20 and -20. So we get -4 times x minus 20 times x minus 20, or x minus 20 squared, equals -1600. Now, our goal is to get it in vertex form, so we want to move the 1600 to the other side, all right, so that it's set equal to 0 now, and we end up with our function in vertex form. So f of x equals -4 times x minus 20 squared plus 1600, all right, and that is our quadratic function in vertex form. Now, part B is asking what is the vertex of the parabola and what's the axis of symmetry. Well, because it's in vertex form, we can easily identify our h and our k. So our h is going to be +20, and our k is 1600. Therefore, our vertex is going to be the point 20, 1600, and our axis of symmetry is just x equals h. So our axis of symmetry is x equals 20. And there's our answers to part B. Now we want to graph the parabola. So first things first, let's label our axes on our graph. All right. And we know that we're going to have to go as high as 1600. So I'm going to go by 200s here in order to label the y-axis. All right. So 200, 400, 600, 800, 1,000, 1,200, 1,400, 1,600. All right. Because we know our vertex is 20, 1,600. All right. Now, our x-axis, we know the middle, our axis of symmetry is going to be 20. So we can go by 5s on our x-axis and most likely be fine. All right. So if we go by 5s here, all right, that should be good. Now let's plot our vertex. We know our vertex is at 20, 1,600. So this point right there. All right. We know that that's going to be our axis of symmetry. All right. Our axis of symmetry is x equals 20. Now, we want to find other points. Now, we could graph this using transformations, but because our numbers are so large, right, transforming our a, right, our slope essentially of our parabola would just be really difficult because we're going up by 1,600. So the easiest thing to do is just make a table. All right, make a table, plug them in, find some points. So we know, we want to see what it's going to be at 0, 0. Let's say what is it at, or we don't know that this is 0. We want to know what is it as when x is 0, 10, 20. All right, well, we know what it is at 20. We know it's 1,600. 30, 40. All right, let's get some of those points. So if we plug 0 into our equation here, right, if we plug 0 in, we're going to get -4 times 0 minus 20 squared plus 1,600, -4 times -20 squared plus 1,600, -4 times 400 plus 1,600, -1,600 plus 1,600 gives us 0. So we know it's 0, 0. For the rest of these, plug it into your calculator. All right, you don't have to do these by hand. So if we plug 10 into our function, we do this in our calculator, we're going to get 1,200. We plug 30 into our function. Use your calculator. Solve parentheses first, square it, multiply by -4, add 1,600. All right, we do that when x is 30, y is 1,200. We plug 40 in, use our calculator, we're going to get 0. All right, now we have an idea of what our graph's going to look like. So we've got our vertex. We know as 0, 0, there's a point, 10, 1,200, 20, 1,600, 30, 1,200, and 40, 0. And there is our parabola. And we just graphed the parabola. All right. If you have any questions on this, please call me over so I can help you. Otherwise, look to the board to see what to do next. And I hope that you have a great day. Bye.